Hi everyone, and welcome to this webinar, our June webinar on imaging the skin in Raynaud's and Scleroderma with Dr. Andrea Murray, who is a senior lecturer at the University of Manchester and Salford Royal Hospital. Andrea is kind enough to do, she'll be kind enough to do a presentation for us for half an hour, and then you'll all have the opportunity to ask any questions. If any questions come to you during the presentation, just pop them in the Q&A box, which you should see at the bottom of your screen. And after the presentation, I'll field some questions for Andrea to answer. Also, Andrea has said she's going to try and keep things very non-technical, but if any really technical language slips through that you don't understand or you would like some clarification on, do please mention it in the Q&A and Andrea will clear it up. So, Andrea is a senior lecturer at the University of Manchester and part of the Scleroderma Research Group. She trained as a physicist, and her interest is developing and applying imaging techniques to understand more about the cause, progression and treatment of scleroderma. She works on some imaging techniques you may be familiar with, such as Nailfold, capillaroscopy and thermal imaging or thermography, as well as some more novel techniques. Recently, her work has focused on improving imaging to enhance earlier diagnosis and provide better ways to measure whether treatments work in clinical trials, and developing low-cost portable techniques to enable patient self-monitoring in the future. I believe Andrea's got 3 studies that she's going to run us through about patient involvement, which will be really interesting. So, yeah, I'll hand over to Andrea if that's all right.
Thanks, Nina, that's fab. Hi everyone, and thank you for the introduction. So as Nina says, imaging, we know well, the skin plays such a key role in Raynaud's and Scleroderma that it's a really good opportunity. It offers those sort of a window onto the disease process. And so because I have this interest in non-invasive imaging of the skin, particularly in Raynaud's and Scleroderma, as a team between the University of Manchester and Salford Royal, we develop and apply these imaging techniques to try and understand more about the processes involved and how we can use those imaging techniques to help patients in their disease management. So as Nina says, I'm just going to run through some of the research studies. So I know this is probably a little bit different from the normal webinars. Some of our research studies that have been shaped by our patients' expertise and how we're using that expertise to help to design research with patients and for patients. And so I'm going to talk about some of our imaging studies that we've run recently. First of all, a mobile phone study to capture Raynaud's attacks with thermal imaging, which you might have come across, and I'll talk a little bit more about that as we go through. We use thermal imaging at our specialist centre at Salford Royal. The second study is looking at improving early diagnosis of systemic sclerosis, which I'll also refer to through the talk with the acronym SSC. And that's also known as scleroderma. And that's using a technique called Nailfold capillaroscopy, which again, you may have come across as part of the clinical pathway of diagnosis. And then finally, I'll move on to a mobile phone app that we've developed to look at tracking systemic sclerosis related finger lesions, which are also known as ulcers, and how they heal with time. So I'll come back through to the different imaging techniques as we cover each of those projects. And as Nina says, if you've got any questions, please do feel free to pop those in the Q&A for later on. So the first study that I'm going to run through is a study of mobile phone thermal imaging as an ambulatory assessment. So by that, we mean something that's portable, that someone could carry around with them as a tool to measure their Raynaud's attacks outside the laboratory. Okay. And you can see in that image that I just showed a mobile phone with a thermal camera attached, and I'll show that image again in a second. So thermography is a technique where we capture the heat that's coming from the skin. It's often known as thermal imaging, or you might hear it called infrared imaging, shortened to IR, or heat imaging. And it's a technique that's used non-invasively, so it's like a camera that we point at the skin and we can measure the skin temperature within those images. And we know that skin temperature is strongly related to skin blood flow. So obviously, we know that in a Raynaud's attack, what happens is that the blood flow sort of stops flowing to those fingers. And so we're able to look at that change in skin temperature that comes from that change in blood flow with one of these thermal cameras. Now, thermography is used in some specialist centres, so we use it at Salford, and the Royal Free down in London also use it. So it might be that you've come across thermography as a way of assessing the severity of Raynaud's when you first come along to the specialist rheumatology centre. If you have come across it in terms of clinical assessment, then it will look something similar to this. So this image on the left-hand side, as you can see, it's very technical. We use 2 upturned buckets because they happen to be the perfect height to put these little jugs of cold water on top. And what we ask is that the patient puts their hands into those jugs with blue, you'll see they've got blue nitrile gloves on. So they put their hands into the water for a minute, and that water is cold, so it's 15 degrees. And what we do then is we take those hands out, we pop them flat on a table, and we monitor them with a thermal camera. So this is an example here in the middle of the thermal camera. And you can see there's a hand on the table down here, and you can see there's an image on the camera there. And these are false coloured images. So this image on the right-hand side, you'll see a scale bar to the right, and purple and black is cold, whereas red and white is hot. So what you see in this image of the 2 hands that have been cooled is that where they've been in the water, up to sort of this area here, we get cold fingers when those fingers first come out, whereas the rest of the arms remain relatively warm. And we monitor that over time to see how well someone rewarms after they've been what's called cold challenged. And that helps us to determine how severe Raynaud's is. It's part of the clinical diagnosis when someone comes for Raynaud's testing. Now, I know it's not a test that's used in all hospitals, so it may or may not be something that you've come across. And don't worry if you've not come across it, because that's okay too, because different hospitals work in different ways. So the background to this mobile phone study is that we all know that we need better treatments for Raynaud's phenomenon, and you'll see me abbreviate that to RP in some slides. But we also know that Raynaud's attacks occur out in the community. So they occur when you go from a warm room to a cold room, when you go outside or you walk down the freezer aisle at the supermarket. And of course, we're not there as scientists and clinicians to capture that data when you're outside the lab. But because these small thermal cameras that attach to mobile phones, which came about in about 2017, they became available. Suddenly, because they're relatively low cost, this allows us an opportunity to potentially ask patients to monitor their own Raynaud's outside of the laboratory to help us understand more of what happens when those Raynaud's attacks occur. And you can imagine this would be a useful technique if, for example, we were trying a new drug and we might want to monitor before and after that new therapy was started to see whether the new drug that you were given for your Raynaud's improved your blood flow in your fingers. So does it maybe minimize the number of attacks that you get, or maybe your hands are not as cold during those attacks once you're on that new therapy. And we realise it might also be a really useful tool to record your Raynaud's attacks between clinic visits as well, so that you can have that conversation with the clinician further down the line and say, you know, I've had this many attacks, and look, these are the images that I've taken from those attacks. So that's kind of the motivation for us looking at this initially as a research tool, but hopefully maybe useful further down the line in a clinical role. And so in order to assess whether or not this was a feasible thing to ask patients to do, we gave patients a mobile phone with a little thermal camera attached, and they took that home, and we asked them to monitor their hands a couple of times a day. And we wanted to understand, was that a thing that someone having a Raynaud's attack where potentially you've got painful hands or numb hands, is that something that's realistic? Can we really ask patients to do that? And if we can, what do those images look like? Are they good enough quality for us to be able to gain data from those images and understand more about how Raynaud's affects people? So you can see here on the right hand side, this is just a standard mobile phone, and connected onto the end of that is a teeny little thermal camera. Here it is on the left hand side, not connected, and you can see it's just held between 2 hands there. So they're not very big, they're quite portable. You connect them to your camera, which is in the mobile phone, and there's a bit of software, there's an app that you download to get those images. And we asked patients to take an image morning and evening without a Raynaud's attack, just so we could understand how much variation there was in that data. And then we also asked them to take any images that they might sort of during an attack, to take images at the beginning, in the middle, and at the end of those attacks, so that we could understand what happens to the blood flow as compared to hands that are not undergoing a Raynaud's attack. And we asked the patients, you know, to rate the overall difficulty of using that thermal camera during an attack, so we could understand, is it likely that we'll be able to take this forward and ask patients to do it in the future clinically? So 13 patients took part in our study, and all of them had Raynaud's phenomenon that was related to systemic sclerosis. Of those, 12 were able to complete the study, and in total we had 352 images that came back, so quite a lot of images. They imaged over a week, and you can see some of the images at the bottom of the screen here. So these are two sets of images. This first person, when their hand is not undergoing a Raynaud's attack, and then this one where you can clearly see the cold fingers here that are falsely coloured purple. That's someone undergoing a Raynaud's attack. And again, a second set of images from someone who isn't undergoing a Raynaud's attack. So you can see those fingers look quite warm. They're sort of the same colour as the back of the hand. And then someone undergoing a Raynaud's attack again at the bottom, where you can see those blue fingers that represent the cold temperature in those fingers. Okay. So the main take home from this is that we are able to see those changes really clearly in people who are undergoing Raynaud's attack. And that's quite exciting for us, because it's not something that we see when we do that cold challenge that I talked about earlier. We choose a temperature for that cold challenge that does not induce a Raynaud's attack in patients, because we don't want to cause pain for them. So it's nice to know that this is a technique that potentially has good use going forwards. And for those patients who were able to image Raynaud's attacks, there were 9 of them, the temperature drop in the fingers was about 4 degrees. So now we have a feel for what having a Raynaud's attack means in terms of what happens to the fingers during those events. And patients rated the overall difficulty as a 3. So out of a scale of 1 to 10, they thought it was pretty reasonable to be able to take images with their mobile phone and those thermal cameras. So that's really good news. So it means that it's not too difficult a task, that we can have a think about how we might be able to improve the usability of that going forwards. So the conclusion for this first study was that our mobile phone thermal images are good images. They're really good quality images, and we can use those to detect the difference in skin temperature in the fingers due to Raynaud's attacks. And that potentially enables a new outcome measure for clinical trials, which if we're trying a new drug, we can potentially use this as a way of measuring how well that drug works for patients who are on that medication. And we do that by measuring before and after that drug was taken. We think this is the first time that temperature of the hands has been measured in this way during Raynaud's attacks. So that's quite an exciting new step for us to take in terms of being able to help patients to self-monitor in the future. And taking mobile phone thermal images of the hands, even when someone's struggling with hand function because of a Raynaud's attack, was feasible for most patients. So again, a really important take home is that hopefully it's something that lots of people would be able to do. And we're going to do some more work. So we're not finished on sort of thinking about this. We've got a new funding application submitted with a project working to further develop this into a technique that we know is reliable. So we know that the data that's used would be the same if we did it one day to the next. And that's going to be hopefully done in a single sensor study. We're going to work with patients. So a big drive to get patients who have this experience and this expertise in Raynaud's to work with us to help to develop these techniques and this device so that it's something that's very usable and easy to use and very relevant to them in terms of being able to self-monitor their Raynaud's at home. And the goal would be that eventually, if we can do all those things and we know that it's a robust technique, then we can potentially use that in clinical trials as an outcome measure, and also for patients to self-monitor going forwards. Okay, so that's thermography, and that's sort of a mobile phone study there. And then I'm going to move on to a different type of imaging, again, one that we use in the clinic. So again, another technique that potentially you've come across. And this study is to try and improve early diagnosis of systemic sclerosis. And I say here in the general rheumatology clinic, and that is many patients who come from their GP will go to a clinic which is not a specialist centre like some of the centres are in terms of systemic sclerosis. So these are frontline clinics where you would go if you had rheumatic arthritis or another rheumatology diagnosis. And the rheumatologists who work in these clinics potentially don't see as many patients with systemic sclerosis or Raynaud's as we do at our specialist centres. And so this study is about how we can help those clinicians make an early diagnosis of systemic sclerosis when it's relevant. Okay. So before I move on to that study, I'm going to flag this questionnaire that some of you may have completed that SRUK ran last year. And this questionnaire was about Nailfold capillaroscopy, and I'll explain this technique in a moment. But there were 262 people that replied to this survey. And some of the questions that were asked were around things like, how long did it take you to receive your diagnosis from first symptom onset? And the point I'm just going to flag here is that, 32%, so 50 out of 159 patients got their diagnosis within a year, which is really good. 64, which is including that 32%, received theirs within 5 years. And ideally, we would like that to be a little bit quicker. And then, of course, there's the remainder of that percentage who received theirs over 5 years from that first diagnosis. And what we're trying to do is really get these diagnoses made much earlier, both because we can reassure patients who have primary Raynaud's phenomenon where there's no underlying connective tissue disease, and also so that we can refer those patients who do have systemic sclerosis to clinicians in order to help that disease management going forwards. So the third point here was that 55% of 201 people who replied to a question attend their closest rheumatology department. So the key point here is that 45% of patients travel in order to go to either a specialist centre or to their systemic sclerosis or Raynaud's clinic. And that's key to what we're talking about here, because potentially if we can roll out our imaging techniques to local centres with our expertise behind that, then potentially that saves patients from having to travel so much in the future. And then the last 2 points here are that 57% of 251 respondents hadn't had capillaroscopy as part of their diagnosis. We know that capillaroscopy helps that diagnosis, so we would like to make that a higher number in order to improve early diagnosis in those local clinics. And nearly 2/3 of those who had capillaroscopy received the test during a follow-up visit, and that timeline for the follow-up visit can be very variable. So again, to get a diagnosis early, we're aiming to try and roll capillaroscopy out in one of those early visits. So when I say Nailfold capillaroscopy, this is what I'm talking about here. It's a little camera that we place on the finger just here below the nail. This is your nail fold, hence the name Nailfold capillaroscopy. And we're looking at tiny capillaries. So you can see here, that's an example of it on the finger. So when I say microscopy, it's a camera that's got high magnifications that allows us to see the really small vessels that you can't see with the naked eye. And those vessels are called capillary. So the fact we're looking at your nail fold and we're looking at capillaries, that's what gives us this quite complicated name of Nailfold capillaroscopy. And it helps us to see the differences between primary Raynaud's phenomenon, so that's when there's no underlying connective tissue disease, and systemic sclerosis or scleroderma. And there's an example here below. I'm going to make that image bigger so that if you're looking at this on a small screen, hopefully you can see those differences more clearly. So here we've got some capillaries that belong to a HC, which in our terminology is a healthy control, so someone who doesn't have Raynaud's. And we often invite people who don't have Raynaud's to take part in our studies so that we can compare and contrast the changes that we're looking at as part of Raynaud's and scleroderma. So you can see those capillaries are all quite narrow, they point in the same direction, they're quite straight. We know that in patients who have primary Raynaud's phenomenon, the capillaries are very similar to those for healthy controls. So they might be a little bit more curly, we might get a little bit more wider in terms of the size of those capillaries that you can see here, but actually they're very similar to the healthy control ones. When we do this live with the patients, you can normally see these are tiny little blood vessels, and the red blood cells are flying through these little blood vessels. So we normally see the blood flowing through these little capillaries that sit just below the nail. So it's a nice technique for patients to be able to see their blood flowing through. And then at the bottom, we've got what we would call a scleroderma pattern, where what happens is sometimes we get a loss of these capillaries and we get a widening of those capillaries. So you'll see these are all taken on the same magnification, but these capillaries here are quite a lot wider than the capillaries that are shown up here. And these are the things that we look for as part of a clinical diagnosis for systemic sclerosis when we use capillaroscopy. So this research project is about the fact that we know capillaroscopy is a key factor in the diagnosis of systemic sclerosis. We use it in some of our specialist centres, although, as I've said, not all of them. We know that that offers us a window of opportunity for early diagnosis. So if we can see these changes early on, when maybe other symptoms of systemic sclerosis aren't there, then potentially that helps us to make that diagnosis. A lot of non-specialist hospitals don't have access to these systems. So we think sort of 40% or thereabouts don't have access to capillaroscopy. But we know that if we were able to help those centres have this system, then potentially we could enable early intervention into scleroderma, reassurance to patients who've got primary Raynaud's, and help patients understand in terms of their own self-management and what to look out for as disease potentially progresses. So how can we change this going forwards? Well, the aim of this work is to bring a low-cost capillaroscopy system to those frontline clinics. Okay. So again, I'll show you this image on the next slide, so it's a little bit larger. But essentially, when people don't use capillaroscopy often, so they maybe don't see that many scleroderma patients, it's difficult for them to remember how to use it to get good quality images. So that's one issue. And sometimes, even when they've got those images, they're not sure how to interpret those images because, again, they don't have exposure to a lot of the images that we see, where we see these scleroderma patterns or lack of scleroderma patterns. And so there can be significant disagreement amongst the experts. And if there's disagreement amongst the experts, you can imagine that someone who potentially doesn't use that system often definitely might struggle to be able to determine what to do next, what decisions to make in terms of disease management next. And so let me show you what I mean here. So this is similar to that first image that we saw from someone who doesn't have Raynaud's previously. And we would say if we saw an image like this is definitely someone who does not have systemic sclerosis. The one in the middle, although a lot of these capillaries to the edge look quite normal, the ones in the middle are definitely enlarged. And so that definitely would be something that would say to us, this would go towards a diagnosis of systemic sclerosis. But the one at the bottom, these capillaries all look pretty normal. There's a couple here at the edge that are just marginally larger than we might think they would be. But that's actually quite a difficult image, even for someone who's experienced in Nailfold capillaroscopy, in terms of how they might interpret that image, what decisions they might make for that patient going forward. And so the project that we're running at the moment is to compare 4 different types of microscopes. 2 of those are low-cost systems. We've recruited 200 participants, some of whom are healthy controls, some have primary Raynaud's, and some have systemic sclerosis or scleroderma. And with those systems, we've taken, you can imagine, thousands of images. We've developed some software that allows us to automatically analyze those images. So to detect, if I go to this next screen here, the top image is an example of an image we've got from a participant in the study. And at the bottom, you can see, hopefully, lots of little blue dots on top of each of those capillaries. And that's a piece of software that has gone through and found all those capillaries in the images and identified them as capillaries. And it allows us to measure how wide those capillaries are and how many of them are present in the image and what shape they are. And all of those things can then be put together in terms of imaging fingers of patients who come to a clinic with Raynaud's to help us to determine whether that patient has primary Raynaud's or whether that patient potentially has scleroderma. Okay. So this project included a lot of user group co-design. And so lots of joint meetings with patients and clinicians who, some of them use capillaroscopy, some of them would like to use capillaroscopy going forwards, and our research group. And the patients, they shared their expertise and their experience in order to help us shape that research in terms of interpretation of the data. How does what we're doing now compare to what's done as the clinical standard at the moment? And what does that mean going forwards in terms of rolling it out to other centres? Data security, so we're thinking about having a system that runs from potentially Salford or somewhere else, into the cloud. Well, what does that mean? Who's going to have access to that data? How can we ensure that it's secure data? All the things that are important in terms of keeping that data safe. In terms of information, we're hoping to generate a report for both the clinician, but also for the patient. So what data would be useful to a patient when they got those images back, in order to help them understand what the images meant and how to interpret those. We talked about technology advantages, how potentially this might help patients who travel a long way for some of these visits, if it could be done more locally. And of course, that also has an implication for costs for the NHS in terms of early diagnosis, helps those patients to get to the right place earlier, and that has a potential impact on the cost to the NHS going forwards. And so we had multiple meetings with patients that were so useful in shaping how that project has has gone on. And we're just moving into the next stage of that project now, where we're looking for a clinician to be able to take an image in a clinic, which is not a scleroderma specialist centre, to upload that into a piece of software, either on their computer or tablet, and send those images to a cloud service. By that, I mean a service that's housed on the internet, and that would have our software on it. It would analyse those images, and then it would return a report via the same computer to both the clinicians and the patients. And that would enable someone who potentially was less confident in taking and in reporting those images to take good capillaroscopy images. So the goals of this second part, this new project going forwards, are to help occasional users, so maybe it's a nurse or an allied health professional or a clinical doctor in the clinic, to take good quality images. And they'll be on the software, there'll be something like an artificial intelligence, in the same way that your phone tells you that an image is blurry or you should put your flash on because the environment's too dark. There'll be guidance to take those images to enable us to have really good quality images, even if someone doesn't use these systems often. And that system will also automatically generate reports for the clinician and for the patients. And we're hoping to roll this out over the next few years across 7 centres to test it and see whether or not it's an easy to use system. So that's sort of where we're up to with that project. And it's been a project that's very much been shaped by our patient expertise. And I'm very grateful to have been involved in that study from that perspective. And then finally, I'm just going to wrap up with another study that we're doing as part of the research, which is called the SELF project, and that's the Scleroderma app for lesion verification. Another project that's very much been guided by patients, so it's been designed with patients and for patients. And this study has been around developing some way of patients being able to record their digital lesions, their finger lesions, and monitor how well they're healing. And again, the background is similar to the other 2 studies, in that we know we need better treatments, and in order to do that, we need better ways of monitoring certain things within the disease, and the patients can self-monitor some of those things themselves. So during COVID, patients sent images of their lesions, their ulcers, to the hospital for clinicians to be able to assess whether or not they needed to be seen in person. And this made the team think that it would be really good if we had a sort of more official way of doing this. And so as part of that, we've developed an app to allow us to image finger lesions or digital ulcers by the patients taking images and sending them to us. And we know that finger lesions cause a lot of problems for patients. They're incredibly painful, they can be difficult to heal, and they're a major unmet clinical need for patients. And we know that if we had better drugs, potentially we could help those not to occur, or maybe to heal more quickly. But it's really difficult, again, because we don't have a good way of imaging those lesions as part of, say, a clinical trial, to be able to go forwards with that. And so the study looked at the feasibility of patients taking images of their own finger lesions, again with impaired hand functions, because we know how painful hands are during that process, with the goal of having this mobile phone app to capture lesions. And we hope that's going to help both clinical trials and patients going forwards. So we assessed the feasibility of patients taking images with their mobile phones, and the feedback came to us that this was good. We developed an app with patients to help patients take those images. And in the background to that, we've developed some software to measure lesion healing. So this is just an example of some of the pages on those apps, that what people see when they go into their mobile phones. So there's guidance to take a picture, there's sort of tips on using natural light, and we use these little green dots attached to the finger just for this study to help us calibrate the size of the lesions that we were imaging there. And the idea is that patients have taken images within the app. They come through to us from the mobile phone to a secure server through the internet. We have marked up some of those lesions by hand, but we've also developed, again, sort of an automated way of finding those lesions in the image. So similar to the capillaries, finding the lesion in the image and doing that automatedly so that in the software, the lesion can be found and the size of it can be measured. And the goal eventually is that we will send that data back. So we'll have a graph of lesion healing that we can send back to the patient that they can either share with a clinician at their next clinic visit, or that we could use again in a clinical trial when someone's taking a treatment before and after the treatment. So just to give you an idea of what we've done so far, most recently, as part of this study, we've had 19 patients complete use of the app, and they imaged 23 episodes of ulcers, and they provided us with 511 photos. And this is an example on the right-hand side of some of the things we've been able to do. So you can see this is a manual markup. So someone's looked at this image of the fingers and they've marked up on the tips of the fingers where the lesions are, and that's done by hand. And then below, what you can see is the software that has been trained by that manual markup here, and then goes into images and finds those ulcers automatically. And so what we hope eventually is that you'll be able to upload images of ulcers, and you'll get feedback on how large that ulcer is and how it's healing with time. So this is an example of an ulcer over 30 days. So patients took the app and they imaged their ulcers for 30 days. You can see it here on day 1, and you can see here on day 30, it's doing quite well, and it looks like it's healing quite well. And this is an example of a size measurement that we've taken. So we've got size here along the 30 days, and you can see the ulcer starts as being quite large, and then over time, even though some days it gets a little bit worse before it gets better, generally by the end of the 30 days, it's healed. And that's the kind of data we'd like to be able to send back on the app when we make our final changes to the app. And again, a study that's really been shaped by patients from start to finish. It's been such a good study to work on from that perspective. Patients have fed back to us on all sorts of things like the size of the text in the app, what kind of buttons we should use, what questionnaires we should use in terms of gathering pain data and sort of disability data, how often we should do those, so they're not too burdensome on patients, whether sliders are better than pressing buttons. When patients struggled to take some of those images, other patients had found workarounds, really clever workarounds of how they were able to take images of their ulcers, even though they had, a lot of pain that meant they couldn't use their phones as well as maybe they would have liked to. And we trialed lots of tripods and remote monitors for taking images. So this was a really good session that we had after COVID when we finally met face to face again. So it was really helpful just to have patients around a table discussing all the ways that we could make this as usable as possible for other patients going forward. So for that final study, we're still analysing all the data, but we know we've got a draft of auto analysis that that will help us to identify the location of those ulcers in the image and to measure the size of those in terms of understanding lesions healing. And we're looking further into understanding how useful that data is to clinicians and to patients. And longer term, we hope to do a multi-centre study and roll the app out to multiple sites so that we can gain even more insight into the usefulness of that data. So just to conclude, I've told you a little bit about some of the imaging techniques that we use clinically and how we've sort of adapted those in our research to hopefully improve both patient self-monitoring and also early diagnosis of Raynaud's and scleroderma. And the skin really offers us that window into Raynaud's phenomenon and systemic sclerosis. So it's a very useful way of doing research. And we use those images both clinically and for research, as you've seen. And our aim is always, when we do our research, to have meaningful impact on the management for both patients with Raynaud's and systemic sclerosis. And it's really lovely that more recently we've been able to shape that research with the patients, with real patient involvement. And I think our projects that I've presented today, they would not have been the same if we didn't have that patient involvement. So I'm incredibly grateful to the patients who take the time out to help us shape that research. And because it's designed by patients with Raynaud's and scleroderma, then I think it has much more relevance for those in the future who will be affected with Raynaud's and scleroderma. So just to acknowledge all of the patients in our user groups, and also the patients who take part in our studies, who give up their time, without whom we wouldn't have the data, and to the many people in our research teams who make this research possible, because it's by no means a solo effort. So there are lots of people involved. And to SRUK for both the invite and for the survey and for all the support we've had from them over the years. Thank you.
Thank you so much, Andrea. That was so interesting. Oh, sorry. That was so interesting. I mean, it's amazing to hear from a researcher's perspective, I think, and I think everyone can agree. Like a lot of our understanding of imaging and diagnosis comes from the clinical perspective. So it's so interesting to hear all the work that comes behind it and before it to lead up to the clinical setting. So thank you so much. Yeah, we've had some comments saying that it was really excellent and comprehensive. Thank you. So I've got a question, which is, where could people, if someone wanted to take part in one of these studies, how could someone go about doing that?
Yeah, so there's so let me make the distinction here. There's two ways that you can take part in studies. So one is to participate in a study, and that means a study's running probably at a centre near you or nationally, and you enrol to actually take part in that study, and for example, take images of your hands on the app or through thermal imaging. And then the other way that I've sort of talked about is through involvement, and that's when a patient becomes part of a user group or a steering committee, and that's about guiding the project from start to finish. So you wouldn't necessarily take part and do that imaging, but you might suggest ways that the sort of research could be shaped in terms of, you know, what does an app look like, and, you know, it could be better if we did this or this or this, you know. So I would say the first thing to do, if you're interested, is you could ask your clinician. So clinicians are often the people who I guess are the face of these studies at the hospitals. So you can ask your clinician if there are studies running that maybe you would be suitable for. And it depends on the centre what kind of studies and if there are studies running. So that's the obvious thing, I guess, to do. Some hospitals may not be running studies. So if that's the case, then there are other options. So we often advertise studies, for example, through SRUK, if like we did with the questionnaire. So it's worth reaching out to SRUK to see if they are aware of any studies that you could take part in. And the clinician may not be running studies, but may be aware of other places that studies are running if they want to take part as well.
Great, thank you. Do you think capillaroscopies could ever be used in a primary care setting, or is that just too beyond into the future?
So it's a question that we both get asked quite a lot, and we've discussed quite a lot. And I think, so my understanding is that a general practitioner, so your family doctor, might only see 1 or 2 patients with systemic sclerosis in a lifetime, in a whole career. They probably see a lot more patients, I guess, with Raynaud's phenomenon. It would be, I suppose it is something that in the future would be a really lovely idea, that especially with a system like this that's sort of portable and remote, that potentially you could expand it out. But I think it's small steps. So I think for us, we know that would be far in the future if it ever sort of came to pass. And I think at this point, our priority is to try and get just rheumatology clinics to have these systems and access to those systems to try and get that early diagnosis, with the hope that the GPs and the family doctors make sure that they sort of refer their patients to those hospitals, and then the diagnosis can be made at that point, hopefully. Great.
Julie has asked, do you have a list of the hospitals that might be running these studies? I mean, I guess that would be difficult, but I'm sure you would know which hospitals are taking part in the studies you mentioned.
So I do know which studies, well, I know which hospitals. So you mean the capillaroscopy study? I guess this is where we're looking to roll out.
Yeah, I guess
so. The 2 that I mentioned, the SALVE study, the ulcer study, and also the thermography study, we don't have a plan of action yet as to where they might be rolled out to. The capillaroscopy study, I think it's still not set in stone. So I think we do have a list of centres. I'm not sure if I'm able to circulate those, but it might be worth, if I say that we will keep SRUK updated on those things. It's they're small studies at this point, so we won't be recruiting a huge number of patients to them. And it would depend on the clinician at that site who was doing that imaging, as to whether or not, who they were going to recruit into those studies.
Yeah, so it sounds like if you're really keen, Julie, then like you said, Andrea, probably your best bet is to ask your clinician and see if they know of any.
Yeah.
Okay. Well, great. If I don't think anyone else has any more questions, so I just wanted to thank you again, Andrea, and just say again how wonderful that presentation was. I really learned a lot, and I think everyone else really appreciated it as well.
No problem. And thank you so much for the invite. So it's lovely to be able to share the studies that have been shaped by patients. It's really good.
Oh, you're welcome. You'll have to come back and we can do a catch up with the outcome really studies. Yeah. That would be amazing.
Yeah.
All right. Well, thank you everyone for attending, and thank you, Andrea, and hopefully we can have you back soon. All right.
Thanks very much. Bye.